When making tap connections from a 1/0 American wire gauge copper water bond conductor to individual disconnect conductors, it's important to understand which methods are acceptable and which are not. Split bolts with tape are not considered irreversible compression connectors. The reason is these connectors can loosen over time, potentially leading to hazardous conditions. Instead, use compression connectors that meet the requirements of Underwriters Laboratories, or UL, Standard 486A. These connectors are designed to create a permanent, reliable connection. This ensures long-term safety and compliance. Regarding grounding, you can bring a single 6 American wire gauge copper conductor from the ground rods to the first main disconnect outside the building, but there are specific conditions that must be met. Firstly, the grounding conductor from the ground rods must be sized in accordance with National Electrical Code, or NEC, Section 250.66, and must be at least 6 American wire gauge. Secondly, the bonding jumper between the first main disconnect and the other main disconnects must be sized in accordance with NEC Section 250.28. D2 and must also be at least 6 American wire gauge. It is essential that all of the main disconnects are effectively bonded together using the grounding conductor and bonding jumper. This arrangement ensures a proper grounding path for all disconnects. It's crucial to consider conductor sizing for the tap conductors from the water bond to the individual disconnects. These tap conductors must be sized in accordance with NEC Section 250.60. D, which requires that the tap conductors be at least 50% of the size of the main conductor, which in this case is 1/0 American wire gauge. This ensures that the tap conductors can adequately handle the available fault current. Additionally, all conductors must be properly insulated and protected from physical damage. This helps prevent electrical shorts and other hazards. Insulation protects against accidental contact with live conductors. Protection from physical damage ensures the conductors are not compromised by environmental factors or accidental impacts. In summary, using UL 486 listed compression connectors is essential for making reliable and safe tap connections. When grounding multiple disconnects from a single ground rod conductor, adhere strictly to the requirements outlined in NEC Sections 250.66 and 250.28. D2, and ensure that all disconnects are effectively bonded together. Always size tap conductors according to NEC Section 250.60. D. Always insulate and protect all conductors to maintain safety and prevent electrical hazards. These practices ensure compliance with the electrical codes and promote a safe electrical installation. Remember to consult the latest edition of the National Electrical Code and local electrical codes for the most up-to-date requirements and regulations. Always consult with a qualified electrician for any electrical work to ensure safety and compliance. The information provided here is for educational purposes and should not be considered a substitute for professional electrical advice. Working with electricity can be dangerous, and it is crucial to take all necessary precautions. Improper electrical work can lead to fire, electrical shock, and other hazards. Therefore, it is essential to have a thorough understanding of electrical codes and safety practices before undertaking any electrical project. Proper grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, helping to trip circuit breakers and prevent electrical shock. Bonding connects non-current carrying metal parts together, ensuring that they are at the same electrical potential. This reduces the risk of electrical shock if a fault occurs. Regular inspections of electrical systems are important to identify and correct any potential problems. Look for signs of damage, such as frayed wires, cracked insulation, and loose connections. Have a qualified electrician perform a thorough inspection of your electrical system at least once a year. This can help identify and address any issues before they become serious hazards. When working with electricity, always turn off the power at the main disconnect before beginning any work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on live electrical circuits unless you are properly trained and have the necessary equipment. Be aware of the potential hazards associated with electricity and take all necessary precautions to protect yourself and others. If you are unsure about any aspect of electrical work, consult with a qualified electrician. They can provide guidance and assistance to ensure that the work is done safely and correctly. Electricity is a powerful force, and it should be treated with respect. By following these safety guidelines, you can help prevent electrical accidents and ensure a safe electrical environment. Remember that electrical codes and regulations are constantly evolving, so it is important to stay informed about the latest requirements. The National Electrical Code is updated every 3 years, and it is essential to have a current copy of the codebook. Local electrical codes may also have additional requirements, so it is important to check with your local authorities. By staying up to date on electrical codes and regulations, you can ensure that your electrical work is compliant and safe. Electrical safety is everyone's responsibility. By following these guidelines, you can help create a safer electrical environment for yourself, your family, and your community. The principles of grounding and bonding are fundamental to electrical safety, providing pathways for fault currents and minimizing potential differences. Understanding the nuances of these principles is essential for anyone involved in electrical work. When dealing with multiple disconnects, the proper bonding and grounding techniques ensure that all metallic parts are at the same electrical potential, reducing the risk of shock. The size and type of grounding and bonding conductors are crucial for effective fault current protection. Using undersized conductors can lead to increased impedance, limiting the effectiveness of the grounding system. Choosing the right connectors for grounding and bonding is also important. Connectors should be listed and labeled for grounding and bonding purposes, ensuring that they can withstand the stresses of fault currents and environmental conditions. Regular inspection and maintenance of grounding and bonding systems are necessary to ensure their continued effectiveness. Corrosion, loose connections, and physical damage can compromise the integrity of the system. Grounding electrodes, such as ground rods and ground plates, provide a connection to the earth, allowing fault currents to dissipate safely. The type and number of grounding electrodes required depend on the size and type of electrical system. The resistance of the grounding electrode system should be as low as possible to facilitate the flow of fault current. Testing the grounding electrode resistance is an important part of commissioning and maintaining an electrical system. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock by detecting small imbalances in current flow. GFCIs should be installed in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or AFCIs, are designed to protect against electrical fires by detecting arc faults in wiring. AFCIs should be installed in bedrooms and other areas where there is a high risk of fire. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning and other sources. SPD should be installed at the service entrance and at sensitive electronic equipment. Proper wiring techniques are essential for electrical safety. Wires should be properly sized for the load they are carrying, and connections should be made securely. Damaged or frayed wires should be replaced immediately. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from overloads and short circuits. Overcurrent protection devices should be properly sized for the circuit they are protecting. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to locate and energize circuits for maintenance and repair. Working with electricity can be dangerous, so it is important to take all necessary precautions. Always turn off the power before working on electrical equipment and use appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code provides detailed requirements for electrical installations, covering everything from wiring methods to grounding and bonding. It is important to be familiar with the NEC if you are involved in electrical work. Local electrical codes may also have additional requirements, so it is important to check with your local authorities. Electrical safety is a shared responsibility. By following these guidelines, we can all help create a safer electrical environment for ourselves and others. Always prioritize safety when working with electricity, and never take shortcuts that could compromise the integrity of the electrical system. By adhering to established codes, using quality components, and employing proper techniques, one can minimize the risks and ensure a reliable and safe electrical installation. In the context of tap connections and grounding, the correct selection of connectors and conductors cannot be overemphasized. Compression connectors, when properly installed, provide a robust and permanent connection that resists loosening over time. Furthermore, ensuring that grounding conductors meet the minimum size requirements as specified in the NEC is crucial for effective fault current protection. Finally, it is always best practice to double-check all connections and to perform a thorough visual inspection of the entire electrical installation to identify any potential issues before energizing the system. These simple yet critical steps can significantly enhance the safety and reliability of the electrical infrastructure.